What's up everyone? So for today's video, we're going to discuss about the modern CPU architecture, the insights and summary. I am John Lennon BRB of BSEE 3B. For the whole semester, we tackled about CPU or Central Processing Unit, its function, the principle, and the basic uses. As a review, CPU sits at the center of everything in the computer and handles all the computation needed to turn inputs from memory, like a photo in your hard drive, into outputs on your peripherals, like an image on your monitor. That is how flexible and unique CPUs are. Looking back to its history and development over time, we all know that CPU is general in purpose and flexible in terms of architecture. Why? CPUs do what we tell them or program them to do. Also, CPU are what run on your operating system, and much more. Talking about its function, CPU is also known as the brain of the computer. And now we'll proceed to what computing abstraction layer or CAL is. For computers to function, it is critical that we represent all controls and data in numbers in simple on or off states. It also turns out that the characters and numbers humans use to communicate with one another can be easily translated into a binary base of a system. Add abstraction layer to abstraction layer to build things up to complex applications that will run large data centers. In general, the abstraction layers that make up computing are well understood and building from one layer to the next. And now we're going to jump from one topic about computing abstraction layers to microarchitecture. Microarchitecture is the fundamental design of a microprocessor, as it includes the technology used, resources, and the methods. Also, it comprises certain implementation details, usually above the level transistors and process technology. Have you heard about ECE, or the instruction set architecture? It is a set of instructions that defines what kind of operation can be performed in a hardware. It is nothing more than the language of a computer. It is an abstract model of the computer as well, as it describes the memory model supported data of machine codes. Times 86, ARMS, and MIPS are some of its examples. And do you know that a modern microprocessor has around 15 to 20 stages? Yes. It includes fetch, decode, execute, and write. To further discuss them, the fetch and decode stages typically have 6 to 10 stages, and they are collectively known as the front end, while the execute and write are also grown into roughly 6 to 10 stages, and they are called as the backline of the microprocessor. And together, they perform in order for the modern microprocessor to function. Have you heard about cache? It is a smaller, faster memory located to a processor core, which stores copies of the data from frequently used main memory location. So, how does primer and caching works? To prime cache means to fill the cache with data so that the subsequent directory server behavior reflects normal operational performance rather than the ramp-up performance. Also, priming cache is useful for arriving at reproducible results when benchmarking and for measuring and analyzing potential optimizations. So that's all for today's video. I hope you learned something about CPU and its microarchitecture.